you must understand that it has to do with straight lines and curves. What are straight lines? Straight lines are this. Example, this is a straight line. For example, this one is a vertical line. A line that is coming up from up to down. These ones, they are vertical lines. Have you seen them? They are vertical lines. We can also call these ones perpendicular lines. We can also call them perpendicular lines. So they are vertical lines, or we have perpendicular lines. Then the ones that go across like this, these ones are horizontal lines. They are horizontal lines. Like the lines you have in your that are drawn inside your exercise books, they go across like this. Those ones are horizontal lines. Then lines that are together are more than one or two, and they are equal distances apart. They are parallel lines. They are parallel lines. So you first get those ones, and I think once you read more on this, you should be able to get, these are the basic lines that we make use of in constructions. Having said that, I will also go to curves, because I said for construction, we basically make use of straight lines and curves. Straight lines and curves. Now, what are these curves? Curves are like this. Anything that is having to bend, as if it is going to form a circle when it's complete. So this one, they are what we call curves. They are what we call curves. And when a curve continues to go, when a curve continues into two equal parts, all we need to do is to take a compass like this. There is a compass like this inside your mathematical set. So you put the smaller pencil here. Don't use the long pencil. You put it here. Now you take this point. You come to the beginning of that first point, maybe A or whatever figure that is there. Then you ensure that your compass is tight, that it cannot just be moved anyhow. Then you now extend it anywhere more than the center. Just observe it, and at least you can see that from the common sense, from the common sight of it, you can see now that this particular pencil is above the center. I have extended it more than the center. Just anywhere more than the center. Even if it's almost taking everything, it does not matter. It's the same thing. Just take it anywhere above the center, and then you describe an arc like this. Have you seen that? Now, without allowing it to extend beyond that, using the same radius of this arc, you come to the other side of it. You take the other, put it at the other end, and describe another arc. Just the way you did the first one. Have you seen it? Now, you just, after describing these arcs, all you need to do is to observe the point of intersection. Take a look at the point of intersection of the two arcs. You have seen out here now that this cuts this here, and this cuts this, the second arc here. So where the two meets is what we call the point of intersection. Then you now place your ruler and be sure that you are exactly at those points where they intersect. Make sure you are at that point where they intersect, and then you make sure that the ruler does not move or shift out of that point. Then you now draw a dotted line. That dotted line is what we call the construction lines. Now look at it. Now with what I have drawn here, I have successfully divided this line into two equal parts. Maybe this is point A and this is point B. And if you measure from point A here to this half, to where this line, this line of this construction line, where it cuts line AB, you will see that it will be the same measurement from that point. Let's call this point where it cuts is point O. So you see that AO is the same thing as OB.